Okay, so our last section we're going to look at in chapter 4 is on radical functions. Okay, so radical functions, that's things like square roots, cube roots. We'll look at a couple things. We'll practice how we can solve equations and how we can graph. Okay, those are all examples of radical functions. Okay, anything that's got that root symbol in it, whether it's a square root, x minus 2, the one next to it, that's a cube root. Okay, any expression that's got a root in it is a radical function. Okay, I'm sure a lot of you guys have worked with square roots, maybe cube roots, but your root can go as high as you want. Okay, for that number n, you can go take a 4th root, 5th root, 6th root, okay, and I'll show you how to do that in the calculator. Okay, but the only kinds of roots you can do are integer roots, okay, positive integer roots. There's no such thing as a 3.5 root, okay, with radical functions. Right? You can take a 3rd root, you can take a 4th root, you don't take a 3.5 root. Okay. Okay, so any expression of this form, okay, where n is an integer greater than 1, is called a radical. Okay, the n, that little number that's kind of in the check mark part of this symbol, that's called the index. Okay, and the thing that's under the root, in this case a, that's called the radicand. Okay, so in the first example up above, x minus 2 is the radicand. In the one next to it, it's x squared minus 1. Okay, and the actual, this like check mark, horizontal line thing, that's the radical sign. It's just naming the different parts of a radical expression. Now, sometimes you put a radical sign and you don't fill in the number. Does anybody know what number you assume is there if you don't fill it in?
1, 2.
2, yeah, square root. There's really no such thing as a first root. Roots start with square root and go up from there. If you want to put in the 2, you can. Most of the time, people don't. Okay, questions on that? All right, let's just look at the calculator real quick and see how we type in square roots and cube roots are pretty easy. Okay, and then after that, we got to do something special to type in higher roots. So square root, you've got a button for it. Just second, square root, type in your number. Okay, cube roots, you don't have a button for, but there's an option in a menu, you can get it pretty quick. If you go to math, and then option 4. Option 4 is the built-in cube root. The cube root of 27 is 3. So cube root means what number times itself 3 times. Gives me 27. 3 times 3 times 3. Okay, if I want to do anything higher than that, okay, let's say you want to do the 4th root of 16. Type in the root you want for first. Okay, 4th root. Go to math, and then pick the 5th option. Okay, it says x root. Okay, what it's going to do, it's going to take the number that I just typed in, 4, and it fills it in for the index. Okay, if I wanted a 6th root, I'd hit 6, go to math, and then pick option 5. Okay, and if I type in, let's see, 16, what number times itself 4 times is 16? 2. 2 times 2 times 2 times 2 is 16. Okay, so any questions on how to type in roots? Okay. Okay, so we just said this. If there's no index, we assume it's 2. Okay, and radical expressions can also be written with exponents. Okay, it's just a different way of writing the same thing. So if you want to take a square root, it's exactly the same as taking the radicand and raising it to the 1/2 power. All right? So if I wanted the square root of 16, I get 4. Or if you take 16 and raise it to the 1/2 power, you also get 4. It's just 2 ways of typing in the same thing. Okay. What do you think a cube root would be? It wouldn't be the 1/2 power. Yeah, it would be the 1/3 power. Okay, so if you want to take a cube root, it's a 1/3 power. How about a 4th root? 1/4 power. 5th root, 1/5 power. Right? It's basically 1 divided by the index. Right? Just a different way of typing it into the calculator. Okay, what power would this be? It's a 5th root. It'd be to the, Justin?
Oh, that's right. Can you say the question?
What, how would you write this as a fractional exponent, fifth root?
I don't know.
Cheryl?
5/4? Or 4/5?
Just the 5th root. What power is that? So like square root is 1/2, cube root is 1/3, 5th root 1/5. Yeah. There you go. Okay, so 5th root, it's to the 1/5. Now, this can be simplified using a rule from Algebra 1. What do you do when you raise a power to a power?
You just have
You add them when you have a power times a power, like this. Yeah, in this case, yeah, you multiply them. So 4 times a 5th is 4/5. Right, so that's a reason why we might write a root as a fractional exponent, so then we can combine them into a single exponent. Okay. This is a little easier to type into the calculator than all of that. Okay, so any questions on rewriting a root with a fractional exponent? All right. So there's really 2 kinds of cases we can have when we're solving for roots. Sometimes we have odd roots, like square root, cube root, 5th root. Sometimes we have even roots. Well, if we have an odd root, we basically are finding the solution to this equation. Okay, and with odd roots, we can always find the answer. Okay, there's not a problem that I could give you that would be like an error if you typed it in. Right, so let's say I said x cubed equals 27. In order to solve this, you're going to have to use a root. Okay? What would you do to both sides to cancel out cubing? Cube.
Add to the power, the 3rd entry.
So what's the opposite of cubing?
cubic.
Cube root. Okay, you take a cube root. All right, so anytime you want to cancel something to a power, you use a root. You could also do the 1/3 power. That's the same thing. All right. So the idea I'm trying to show you here, if you have an equation in this form, you're going to have to take a root to solve it. And now you get x equals the cube root of 27. Either type that into your calculator, or if you just know it, just write it down. Right. Now, when n is even, okay, like square roots and 4th roots, this is important. Okay, I'm saying that the radicand can't be negative. Why not? Why can't the radicand be negative with, say, a square root?
Imaginary?
Then it would be imaginary. Okay, and in this section we're not dealing with imaginaries. All right, so when you're solving for a principal root, first of all, we're looking for a single answer, and we're looking for an answer that's not imaginary. Okay, we're looking for a real solution. Right, so in this kind of problem, you might have x squared equals 36. Okay, and John, what would be the opposite of squaring?
Square root.
Yeah, you'd square root. Okay, so if you have an equation like that, you're going to have to use a square root. And we get x equals, What times what is 36? 6? Any number times itself, that's also 36? Yep, negative 6 times negative 6. But when they're asking for the principal root, they don't want the negative answer. Okay, so principal root means two things. One answer to the problem, and it's not imaginary. Okay, any questions on that? All right. So now I want to look at just kind of the behavior, okay, of a square root. Okay, when you have a number and you take a square root of it, does it get smaller? Or does it get larger? Smaller? All right, let's try one. All right, so for example, if x is 4, what's the square root of 4? 2. Okay, so yeah, it got smaller. Okay, let's try 18. Okay, for this one, I'll just type it in. I get about 4.24. Smaller or larger? Smaller. Okay, the square root is smaller than the original. How about here? What's the square root of 1? 1. So smaller or larger? Same. Okay, so sometimes it gets smaller. Sometimes it stays the same. Let's try the square root of 0.5. Square root is 0.71. Smaller or larger? This time the square root is larger. Let's try, take the square root of 0.2. 0.45. What do you think determines whether the square root gets larger or smaller?
Decimal point.
When it get bigger, when it
There's relation to 1.
Yeah, it all depends if it's above 1 or below 1. Okay, and not negative. So is it between 0 and 1? Is it equal to 1? Or is it more than 1? More than 1 gets smaller. Less than 1 gets larger. Exactly 1 stays the same.
So does this kind of have to do with those like graphs that we were doing?
Yep, we're going to look at graphs right now. That's going to be our next
On
step.
either side of it?
Yeah, yep, we're going to look at some graphs. Okay, let's graph a couple roots. Okay, let's graph a square root, a fourth root, and a sixth root, all on the same screen. All right, so let's graph. Here's my square root. Okay, now to do fourth root, I'm going to press 4. Go to the fifth math option. Put in x, that's a fourth root. And let's graph a sixth root. Okay, I'm just focusing on even right now. Because even roots and odd roots, they don't look the same. So sixth, math, fifth option, x. All right, so let's start with zoom 6, and then we'll adjust our screen to see this a little better. All right, so there's our square root. There's our fourth root. And there's our sixth root. Okay, everything here is in quadrant 1. So first thing I'm going to do, I'm going to get rid of quadrants 2, 3, and 4 just by setting my minimums to 0. Also, if you noticed, it didn't go very high. Okay, I don't think we need to go as high as 10. Let's set it at 4. Does anybody notice a point that it looks like every one of those graphs has in common?
Yeah.
Yeah, 1 comma 1. Every one of these graphs goes through 1, 1. And there's also another point, it's a little harder to see. Yeah, they all go through the origin. So 0, 0, and 1, 1 are common to every graph. Okay, and what else can we look at? What's the domain here? You can't see it as well because I changed my minimums to 0. But when I did these graphs go into the negative x-axis? No. So the domain was all numbers from 0. How far to the right do they go? Yeah, infinity. So the domain you can plug in any number from 0 bless you, to infinity. Now, everything I'm writing here, these are just the basic functions. Okay, you're not doing something like this. Okay, that's going to change it a little bit. Okay, you couldn't plug 0 into this one. 0 minus 3, that'd be a negative number. Okay, we're just talking about basic, no other numbers, just square root, fourth root, that's it. Okay, how about the range? How low? What's the lowest value, and what's the highest? The highest? No, it's going to go higher than 3. Infinity. Okay, these graphs, doesn't look like they're going up quickly, but they're going to keep going up, especially the black one. Looks like it goes up very slow, and it does, but it goes up forever. Okay, so the lowest is 0, and the highest is infinity. All right, the other thing I want to look at is that idea of whether the square root gets smaller or larger. Okay? So if we look at our graph here, after 1, okay, it's pretty clear that if you take a 6th root, that makes your number a lot smaller than if you took a square root. Okay, does everybody agree with that? After 1, the 6th roots are a lot smaller than the square roots. In fact, they're the smallest. 4th roots are kind of in the middle. Square roots are the highest. But let's see what's happening between 0 and 1. Okay, let's kind of zoom in on, just look at that part. All right, so let's set our window, let's go maybe to 2. 2. Let's try that. Okay, what happens between 0 and 1? If you look at the relationship of the black, the red, and the blue line to each other.
Opposite of what's past 1.
Yeah, they switch places right at 1. It's the opposite. Okay, so between 0 and 1, if you take a 6th root, that's the biggest. If you take a 4th root, that's still the middle. And if you take a square root, that's the smallest. And then at 1, they all switch places. Right? That has to do with what we just looked at right here. 1 is where the behavior changes from getting smaller to larger. And it's the same behavior for all even roots. Okay? If I were to graph, let's say I were to graph like a 8th root, okay? After 1, the 8th root would be the smallest, and before 1, the 8th root would be the largest. Okay, so any questions on the idea of even roots? All right, now let's take a look at odd roots. Okay, I'm going to do the same kind of thing. This time I'm just going to graph, let's say, a 3rd root and a 5th root. All right, so I'm going to type in 3, math, 5, okay, and 5th root, math, 5. Okay, we'll start with zoom 6 and see what that looks like. Okay, what's a big difference right away you could see on this one? It's what?
That has not run into origin.
Yep, it goes through the origin. Okay, in fact, both graphs go right through the origin. What else looks very different about this one? Yep. Yeah, it goes both directions. Okay, odd roots go in both directions. Let's zoom in a little bit. Let's try looking from, let's try -2 to 2. Okay, on the x. And let's try the same thing on the y. -2 to 2. Okay, let's check for any points they have in common. Anyone think they see a point that both of these graphs go through?
There's 4.
Yeah, they both go through the origin. Okay.
1 and 1.
1, 1, yeah, they both go through that point.
-1 and 1.
-2, -2.
negative 1 and 1.
Yeah, -1, -1. Those 3 points are common to every odd graph. Now that's assuming, again, you're not going to transform it, you haven't shifted it, just the basic graph. Right, -1, -1, 0, 0, and 1, 1. Okay, and next thing we'll look at the domain and range. Okay, look at the difference between that and even roots. Okay, and the domain and range, quite a bit different, and Taryn already said something about it going left and right forever. So what's my domain here?
All reals.
Yep, all reals. What about my range? All reals. It's going to go up and down and left and right forever. Okay, and in this one, there's all kinds of weird behavior. Okay, the red one is on top in a few different sections. Okay, and the red one, which one was that? That was our fifth root. Okay, so the fifth root is on top anytime you're less than -1, or if you're between 0 and 1. The red one is on top. And then the red one is below anytime you're between -1 and 0, and then anytime you're beyond 1. Okay, so there's a lot of overlapping here. Okay, but I just wanted you to see that overlap, that's all. Okay. Questions on that? All right. Okay. All the transformations that we've done so far, it's exactly the same with roots. And I labeled them in the order you would do them. A, B, C, then D. Okay, if we need to, we can write them down. Does anybody remember what A does when you add or subtract inside your function?
No.
Yep,
Shifts left and right.
perfect. That's your horizontal shift. Okay, B, let's come back to B in a second. How about C, when you stick a number in front? Yeah,
Rotate, yes. Expand and shrink.
which way, vertical or horizontal? Vertical, yep. That's your vertical stretch. Which could be a compression if it's a fraction. How about D, when you add or subtract a number on the end? Yeah,
Up and down.
yep, that's your vertical shift. So what does that leave for B? Could be, if B was negative. If C was negative, that could also cause a reflection. What's the only one missing here?
Horizontal stretch.
Horizontal stretch. Okay, and remember, all the horizontal stuff does the opposite of what you would think. Okay, if you see plus, plus actually shifts it left. Minus shifts it right. If you see a big number in front of B, you might think, oh, big number is going to make it bigger. No, not horizontal. Big numbers compress it, make it smaller. Small numbers for B would actually make it bigger. Okay, so horizontal does the opposite of what you would expect. Vertical does exactly what you would expect. Plus is up, minus is down. Big number for C makes it bigger. Small number for C compresses it smaller. Okay, so you just got to be careful with the horizontal stuff. All right, so all I want to know here is if I had the graph of square root of x, what would be the difference between these two graphs? So to get g of x, what would you do to square root of x? This is like your A up above. Just be careful the direction. Yep.
Move the graph 2 units to the right.
Yeah, that's going to move the graph 2 units to the right. Perfect. So to get g of x, shift square root of x, right 2. Okay. How about h of x?
3 into that.
Yep. So to get h of x, shift square root of x, left 3. Okay, and k of x. Be careful before we even start to do this problem. What should we think about doing first? Yeah? Right, this is not the standard way we normally write it. We always put the x first. Okay, now there's 2 things happening. Okay, the negative is going to do something. That's like your b. Think of it as -1 if you want. And plus 3, okay, that's like your a. Amanda, what's the plus 3 going to do?
It's gonna shift left.
Yep. Okay, we just did that up above. So shift left 3. And this negative. Okay, somebody already mentioned what negatives do.
Flips on.
It's going to flip, and it's going to flip horizontally. Okay, this is horizontal flip. So which axis would that flip over? If it's going to flip horizontally, it flips over the y-axis. If it flips vertically, like that, that's over the x. Okay, so just say flip over y-axis. Okay, so you'll probably have a question on the test that just says, here's a graph, here's the base one, tell me how to transform it. Any questions on that? All right, so last 2 things. So we're going to look at sketching. Okay, we'll sketch probably one even and one odd, and then we'll finish up with solving an equation. Okay. All right. First thing you want to do when you're sketching a graph is find the point that corresponds to 0, 0. For an even function, I call this the start point. It starts from here, and it heads out in one direction. For an odd function, I call it the center point. Okay, remember what an odd function looked like. 0, 0 is kind of the center, and it goes out in each direction from there. Kind of like that. So either way, you want to find this point, whether it's your start point for an even function or your center point for an odd function. And that's how you find it. Okay, to get the x value of the coordinate, just set what's under the radicand equal to 0 and solve. To get the y value, well, once you have the x value, plug it in, and you'll get the y value. Okay, once we have that point, then we want to graph a few points to the left and to the right. Only if it's an odd function do we go in both directions. If it's an even function, we just have to pick points in one direction. Okay, so I might just find 4 points and then make my sketch. Okay, for odd, probably find a couple points like that, and then maybe a couple in there. Okay, and you can use your table on the graphing calculator to do that. Okay, but just remember, odd functions, both directions. Even, one direction. Okay, and that's it for graphing. So let's just try one odd and one even. Okay, there's a lot of transformations here, but it doesn't matter. Okay, we're not listing out all the transformations. Okay, is this going to be a graph that goes in both directions or just one direction? Yeah, it's going to go in both because it's an odd index. Okay, and what's the first thing I do? Yeah.
You're gonna get 2x in front, maybe 2x.
You know what? If you were going to write out the transformations, I would do that, just so you had everything in the proper order. But since we're not listing the transformations, we can go right to this step. Set the radicand equal to 0. Okay? So just take this, set it equal to 0, and solve. And so x is 1.5 or 3/2. Okay, Matt, once I get my x value, how do I get my y value? Yeah, we just plug it back in. Okay, think of this equation. If you were typing it in on your calculator, it's y equals. Right, so Pat, if I plug 3/2 in, what do I get under the radicand? Well, what did we get for x when we did the first step? 3/2. And we got that because we set this equal to what number? 0. Right? So we already know what we're going to get if you plug 3/2 in. We should get 0, unless we solved it wrong. Right? So you plug in 3/2 here, you're going to get 0. What's the cube root of 0? Tyler?
Cube root of 0?
Yeah.
0.
Times 2?
0.
0 plus 1. 1. It's basically just the number right at the end. Okay? That's a point on my graph. 3/2, 1. Okay? Now I'm going to get a couple other points, but I'm going to use my table. Next, let's type it in. Okay, when you type these in, it can be kind of a pain if you have this number in front, because if I type in the 2 and I put the 3 right next to it, it's going to do the 23rd root. Right? So the way I got to do it is 2, I have to press times, now press 3, math, 5. Okay, that's how you have to do it. So it's 2 times the cube root, 3 minus 2x, plus 1. Be careful you don't put the plus 1 under the root. It's got to be on the outside. Okay, now we said that this is a graph that goes in both directions. Okay, so let's just check some points, okay, to the left and to the right of 3/2. All right, so if your table's not on Ask, I would do that. Let's check 4. We're at about negative 2.4. I wouldn't round to more than the 10th because we're going to graph this by hand. We can't graph much more accurate than that anyway. Let's get one more. 10, negative 4.1. Okay, and get a couple on the other side of 1.5. Let's try negative 4. It's about 5.4. And negative 10. About 6.7. Okay, for the homework, if you need graph paper, I printed some graph paper out. All right, and just make our sketch. All right, so 1.5 comma 1. That's our center. Then we got 4, negative 2.4. Let's see, 10, negative 4.1. Okay, that's one side. And the other one, negative 4, 5.4. Negative 10, 6.7. Okay, if you feel like you need more points, go for more. I think that's plenty. Yeah, let's compare it to what we should have gotten. Okay, notice how the calculator drew a little gap. Okay, it couldn't connect it. That's because in that section it got steep. All right, there shouldn't be a gap. But that's basically what we got. Yeah?
So 3 has 1 is the x of
Yeah, yep, basically that's that center point. Yeah, I didn't draw it perfectly symmetrical, but yes. Yep. Okay, so any question on sketching an odd function? All right, let's try, try an even. See if you can do that one on your own. Okay, this time it's not a center point, it's going to be the starting point, and only check points in one direction once you find your x value. Okay, if you try them on the other side, you're going to get negatives. It'll just say error when you type it into the table. Okay, so give that a shot. Okay, if you need to help, help your neighbor work together. And I'll walk around and help you guys out. All right, let's take a look at this one. Okay, what's first thing I got to do?
Plug it into the calculator.
Okay, so we could type it in now. We could type it in later, but yeah, we got to type it in eventually so we can use our table. But what's the first coordinate we want to get in our table?
You want to set the rise to equal to 0.
Yeah. Set that equal to 0. And what do we get for x? 4/3. Okay, so for graphing purposes, it's about 1.3. And if you plug 4/3 back in, what do you get for y? Well, Dalton?
You get
Or actually, just start with this part. If you plug 4/3 into here, what do you get?
I didn't do it that way. I just plugged it right into the table.
Oh, into the table?
Yeah, so I guess I missed a step there.
Anyone help him out? What do you get when you plug that in? Yeah.
1 or no?
I hope not.
0.
0.
Oh, yeah.
Okay, we set this equal to 0 and solve for x. So this should be the number that when you plug it in, gives you 0. All right, so that's 0. 4 through to 0?
0.
0 times 3?
0.
Negative 2. Okay, so I'm going to look for this start point when you do your graphs, okay, on the test. You got to have that start point. Now we can use the table.
Does the start point have to be in a decimal form, or can we have a fraction form?
Fraction's fine. All right, so now this only goes in one direction. We're either going to plug in numbers bigger than 4/3 or smaller. Okay? Just from the old numbers I have, you can tell it's not bigger. This graph doesn't go to the right, it goes left. Okay? And that has to do with this negative. It flipped it. All right, so plug in numbers smaller. -4, actually that's a good one. Get a nice answer. -10, that's fine too. 5.2. Okay, let's get the graph. Right, so right 1.3 down 2. And -4, 4. And -10, 5.2. Right, so make your sketch. Okay, let's compare that to what the calculator shows us. Okay, is what the calculator drew and what I have look the same?
So, yeah.
No. Okay, it looks like the calculator is starting it above the y-axis. Okay, and the reason is when it starts to get steep, calculator can't draw it anymore. If you zoom in, okay, zoom in right at that axis, it'll probably show it going a little lower. Let's just zoom in right there. So before it was above the axis, now it is going below, but it's still not going as low as it should. All right, so just be careful you don't always trust the graph. You got to find that start point. That's why I had you do that. Okay. Questions on that? Okay, so be careful. All right. And last thing, okay, so solving equations. Okay, for this part, I don't think you'll need the graphing calculator. Okay, anytime you want to solve a radical equation, okay, the goal is to get the radical by itself. Okay, if you had this, That's a problem where the radical is not by itself. The first thing I would do to isolate this radical is do a +5 on each side to make the problem this. Now the radical is by itself. You can have other stuff under the radical, just nothing on the outside of it. Okay? Just the radical is by itself. And then you want to cancel the radical out. So in this case, if I'm square rooting, I'm going to cancel it with a power of 2. I'm going to square. Okay, in this particular problem, I would square each side, and I'd have x plus 2 equals 225. And then my last step would just be minus 2 from both sides. So the answer here would be 223. Okay, we don't have to do it more than once. We just square each side. Okay, sometimes we have to do it twice. Okay, but we'll start out with one that we just have to do it once. Okay, make sure you always check your answer to make sure it's not extraneous. Okay, so sometimes you do everything right, you get an answer that just doesn't work. All right, so in this one, is the radical already by itself? Yeah. There's nothing else on the outside of the radical. Okay. Jamie, what kind of root is that? It's a cube root. So Justin, what's the opposite of cube root?
Cube.
Cube. Okay, we're going to cube each side. Cube, cube. Right. So now we've got x squared minus 2x plus 2 equals x cubed. Okay. Derek, when we solve equations with higher powers, we try to get what number by itself on one side? Number.
0.
0. Yeah, like quadratic formula. We try to get 0 on one side. So I'm going to bring the x cubed to the other. Well, we have two ways we could do it. You know what, for this one? I know it seems like a lot more work, but I'm going to move everything that's on the left to the right. Okay, just because I like the highest term to be positive. You'll see why in a second. X cubed minus x squared plus 2x and minus 2. Okay, if you want to do it the other way, go for it. That's fine. Okay, Paige, what do these first terms have in common?
X.
Yeah. Yeah, even more. You could take out x. I think x squared would be even better. Right, and how about Kyle? What does that leave me with inside parentheses?
X minus 1.
Perfect. Okay, and watch what's going to happen here. That's also going to leave me with x minus 1. Okay, I made that happen on purpose. If it didn't, we'd be stuck right now. Okay. What do both of these have in common now? X minus 1. If I take x minus 1 away from the first one, what am I left with? Just x squared. Take it away from the second one. Just a plus 2. Now, we're multiplying two things together, and we're getting 0. Okay, the only way that can happen is if one or both of these equal 0. So either that has to happen, or that has to happen. Okay, what's the solution to this first one? 1. What's going to happen on this second one? We'd have the square root of negative 2, which is what? It's imaginary. So we don't worry about it. Okay, we don't get an answer from that part. Okay, if this had been like x squared minus 2, then that would have changed the sign, and then we would have gotten another answer. You don't even have to write extraneous. If you want, you can write extraneous.
We just leave it like that.
But yeah, make sure you cross it out. Okay, on the test, if you forget to cross it out, you'd lose a point for that part. Okay, and let's just check, make sure it works. Nick, what's 1 squared? 1 minus 2 times 1,
minus 2.
and then plus 2. What's 1 minus 2?
Negative 1.
Negative 1 plus 2,
1.
and the cube root of 1?
1.
1. So you get 1 on the left. If I plug in 1, 1 to the third power, is that also 1? I get 1 on the right. 1 equals 1. That works. Okay. Any question on that one? All right. Last one, this is a calculator one. So we're not going to do any algebra with it. All we're going to do is plug it in and see where this is higher than that. So the hardest thing with this is just making sure you know how to type it in. So 5th root of 9 minus x squared. And x squared plus 1. Okay, so the way I typed it in, I'm looking for where the blue line is above the red line.
You put 9 plus x.
Oh, should be minus. Thank you. Yeah, that's important. Right, so we're still going to look for where the blue curve is above the red. Okay, there's my blue. And I want to know where the blue is higher than the red. Where does that happen? Yeah, just in these spots right here. That's the only spot on this graph where the blue is higher than the red. Everywhere else, it's lower. Okay, so what do I have to do to find these points exactly? Yep, second calc, intersect. Okay, so between negative 0.73 and I can equal. Okay, up to, what is it? One.
Y plus 1.5.
Yeah, I need the other x-intercept. 0.73. All right, so yeah, I guess it's almost symmetrical. Negative 0.73 to positive 0.73. Okay, any questions on that one? That's all you have. Just use your calculator. All right, so I think that's good for today. Okay, the homework's on 255. It's 5, 6, 12, 14. 20, 21, and 22. 28, 31, and 35. 28, that one's a little tricky. Okay, so if you get stuck on 28, don't worry too much about it. We can look at that one tomorrow. Okay, but that's one where you'd have to square each side twice. I'll show you one of those tomorrow.